In this video, we're going to look at the interior and exterior angles of polygons. A polygon is simply a two-dimensional shape with three or more sides. So an example could be a triangle, a rectangle, a hexagon, or an octagon. Circles are not polygons. Let's start by drawing a triangle. So we've got a triangle just here, and I'm going to go ahead and mark on the interior angles. So this now is an interior angle, it's on the inside. This one is an interior angle, and this one is as well. So you've got three sides and three interior angles. I'm now going to extend these side lengths and look at what we call the exterior angle. The exterior angle is on the outside. So if we just extend this line right here, and I'll extend this one down here. So that's what we're going to have. I'm going to draw these on. The exterior angle to this one will be just here. As we can see, these are on a straight line and will sum to give 180 degrees. With this one, we've got the angle just here. These two will sum to give 180 degrees. And then finally, we've got this one. You might have asked the question, why did I extend the line in that direction? Why didn't I extend it in this one like I had with the other? Well, if we think about opposite angles, these are going to be the same. So we've got the green one and the pink one will be opposite, therefore they're equal. So if we look at this now, if I put on here that this was going to be A, this was going to be B, and this was going to be C, we could see that A plus B would give us 180 degrees. We can also see that B plus C would give us the 180 degrees. A and B, we can write just here, A is equal to B. They are opposite angles. So the sum of the interior and exterior angles will give us 180 degrees. In the video, we're going to look at a few different concepts. We're going to look at the sum of the interior angles of any polygon. We're then going to move on and look at regular polygons and look at the individual interior size of an angle and the exterior angles. So let's go ahead and start off. What we've got here are a range of different polygons. These are not regular polygons. So regular polygons will have equal side lengths. If we consider the sum of the angles in a triangle, we know that that's going to give us 180 degrees. The sum of the angles in a quadrilateral, if we think to begin with, the nice easy example, is a square. So if we go ahead, let's just draw a square. We know that we have four right angles. So if we put this one on, four same right angles, I should say, in the different corners. So we will sum to give 360 degrees. As we can see from this, every time I include a side length, so I've gone from three sides to four sides, I've added 180 degrees. If I take this four-sided shape or quadrilateral, what I'm going to do is look at how many triangles I can fit in here. So I'm going to pick one of the vertices and then go ahead and draw a line. The line is going to connect this vertex with the only other one it's not connected to, which is this. We can see now that that gives me two triangles. So here I have one triangle, which is 180 degrees, and this one just here, which is 180 degrees. So if I added that one to that one to that one, that would give me 180. If I added that one to that one to that one, that would give me 180. So we can see now we have a combined total of 360 degrees. So if we look now, the sides on this one are going to be 4, and we can say that the number of triangles is 2. With this one, the number of sides is 3, the number of triangles is 1. Let's now look at a five-sided shape. 1, 2, 3, 4, 5. So picking any one of the vertices, I'm going to pick that one is unconnected, and then this one is unconnected. I can see now that I've made 3 triangles in here. So I've increased the number of triangles by 1, so 180, 180, and then we're going to have 180. We can see from this now that the sum of the interior angles is going to give us 540. So here we can say now I'll just put sum is going to be equal to 180. We've got now the sum of the interior angles is 360. With this one, we have the number of sides. The number of sides is going to be 5. The number of triangles is going to be 3. And the sum of the interior angles is 540 degrees. Let's now take a 6-sided shape. So I'll pick this vertex and I'll go just here. That's one triangle. I need to connect that one. And finally, I need to connect that one. All of the others are connected up now. If we look at this, I've now got a triangle just here. So the sum of the angles in that triangle are 180. 180, we've got 180, and we've got 180 degrees. So the number of sides is going to be 6, the number of triangles is going to be 4, and the sum of the interior angles is just 720. All I'm doing is adding 180 on each time. So if you think about this, this seems fairly reasonable. If we look, the difference between the number of sides and triangles is 2. To find the sum of the interior angles of any polygon, we simply do 180 multiplied by n minus 2, where n is the number of sides. If we look at this one now, taking n to be 3, we've got 3 different sides. All we would do is say now for the triangle, the sum is going to be 180, and we've got 3 minus 2, which is 1, which is going to give us 180. If I look at this one, we've got 180, and then we're going to multiply that by 4 minus 2, which is 2, which gives me 360. So we can look at the next one, a 5-sided shape. 5 minus 2 is 3, so we need 3 triangles, 540. If we look at the next one, we need 4 triangles for a 6-sided shape, and that gives us 720. So if we wanted, we could find one with 10, so the sum of the interior angles, if we had 10, we'd simply do 10 minus 2, which is 8, and then we'd have 8 multiplied by 180, which will give 1460, I think. Let's just do that. 8 times by 180. Let's just check that. What have we got? 1440. So we could say now for a 10-sided shape, so 10 sides, the sum of the interior angles will be 1440 degrees. So this holds true for any polygon. We're not yet looking at regular polygons, but of course this will work. So let's go ahead and draw a polygon. So here is my polygon, and then we'll have another side, and we'll have that side just there. Well, let's just make that a little easier to work with. A typical question we might have now is that we might be given some of the angles. Let's say we were told this one right here, we'll say that that's going to be now 100 degrees. So 100 degrees, we'll say that this one, I'll say that's going to be 100. This is not accurate, of course. We'll say that this one is going to be 110. And this one right here, let's say that's going to be 150. And we might be asked to find the size of angle X. If we just consider now, we have a 5-sided shape. So for a 5-sided shape, we would do 180 multiplied by 3, which would give us 540 degrees. So the sum of the interior angles is 540. If we add these up, we've got 150, 250, 350, and then we have the next one, which is 460. So we can say 540 minus the 460 will give us now the value of X. So that's all I need to do to find that, and I can go ahead and do that. As we can see from that, that will give me that X is going to be equal to 80 degrees. So we're using now the angle facts that the sum of the interior angles give us 540 degrees. This question might be extended. We might have, for example, now, let's say we were given that just here, let's say that continued right here. We might be asked to find the size of angle Y. So let's just go ahead and put that on. We'll say that angle Y is going to be just here. So this is angle Y. We've got the interior and the exterior. So we can say that Y plus 110 will be equal to 180 degrees. So we can see from here that Y would be 70 degrees. We're simply subtracting the 110 from 180. So that is looking at the sum of the interior angles of any polygon. We work out how many sides we've got, we take 2 away from it and multiply it by 360. With these irregular shapes, all of the angles, as you can see, are often different. With regular shapes, the angles will be the same. So let's look at one more question. We're asked to find the sizes of angles A and B in the diagram below. So we've got a 4-sided shape, a quadrilateral. We know that the interior angles must sum to give 360 degrees. So we can say on here, sum is going to be 360 degrees. So that is what I'm going to write. So if I just manually add these up, 80, 200, 260, therefore this would be 100 degrees. Clearly in an exam you would go ahead and do a bit more working and show exactly what you're doing. If we think now we've got the interior and the exterior, they sum to give 180 degrees, so B on a straight line gives us 80 degrees. We're now going to move on to regular polygons. There's lots of different approaches to finding the interior and exterior angles of polygons. Hopefully now I'm going to show lots of different ways we can deal with the regular polygons, and you can kind of make up your mind or decide which you prefer. Lots of different books will present it different ways. So let's start off. We've got a triangle. So what we're going to do now is consider the interior and exterior angles of the triangle. Remember, the exterior angle will be this one on the outside. We can say now for a regular shape, the exterior angles, and we can write this on, the exterior angles will be equal to 360 divided by n, where n is the number of sides. This is one approach. Now if I think about this here, if this is regular, so all of these side lengths are the same, all of the angles are going to be the same. So if I took the triangle, 360 divided by 3 gives me 120. So this is going to be 120 degrees. Therefore, now on a straight line, the interior angle is going to be 60 degrees. We knew that was the case anyway, as we have an equilateral triangle. But we can simply find now the exterior angle by doing 360 divided by the number of sides. So you might have thought, well, in that case it's pretty pointless. As you'll see later on, it can be quite handy. Alternatively, what we could have done is looked at the interior angles. We know for the sum of the interior angles, we can say now, so this is the exterior, so sum of the interior is going to be now 180 multiplied by n minus 2. So we know that we have 180 multiplied by 1, and that's going to give me 180. So the sum of the interior angles is going to now give me 180 degrees, and we would divide that by the number of sides, as it's now an equilateral triangle, or if you like, a regular polygon. So if we'd done that, we could have said that each of these angles are the same. We've got 3 of them, so we're going to end up with 180 divided by 3, which is 60. I personally prefer working out now the exterior on a straight line and subtracting that. We can see quite clearly now that the sum of the interior angles is 180, as we knew. So I'm going to write that the exterior is going to be equal to 120, the interior is going to be equal to 60, and the sum of the interior is going to give me 180. So with the triangle, hopefully now you can see why and how that works. Let's now take the square. So if we take the square, let's go ahead and extend this. The exterior angle is 360 divided by the number of sides. 360 divided by 4 gives me 90. We know that the angles on a straight line sum to give 180, so this must be 90, and of course we have 4 of them. So we've got now 90, we've got the 90, and we know that. Hopefully these first couple of shapes are confidence building questions to show you that this works. So to find the size of now the exterior angle of a regular polygon, 360 divided by the number of sides. So the exterior is going to be 90. The interior, each of the interior is going to give me now 90, and the sum of the interior will give me 360. Again, you might want to draw how many triangles you can get into it. Okay, let's now look at this five-sided shape. So we've now got on here our pentagon. Let's put that on. So I'm going to find now the exterior angle, the size of each interior angle, and the sum of the interior angles. We could go around this a different way. So if we think now, we know, and I'm going to show different ways of doing this. This is entirely up to you. I'm going to say now that the sum is going to be equal to n minus 2 multiplied by 180. So that's going to give us 3 times by 180. So the sum of the interior angles is going to give us 540. I now have 5 angles that are all the same. So if I wanted to find the size of each, I would simply divide this by the number of angles. 540 divided by 5 is going to give me 108. That is 108. That is 108. That's 108. And as you can imagine, that is 108. Angles on a straight line sum to give 180. So the exterior must be 72 degrees. What could have we done instead? Well, let's do the exterior. The exterior would be 360 divided by the number of sides, which is going to give us 5. And that would end up now giving me the exterior angle. So if we do that, 360 divided by 5 is going to give me 72. So I know that the exterior angle using this property is 72. I could therefore find the interior angle, and we could simply multiply that number by 5. So it really is up to you. Let's now go for the six-sided shape. So on the exterior, I'm going to find the exterior. Now the exterior is going to be 360 divided by the number of sides. We've got 6 sides, 360 divided by 6 is 60. Therefore, we're going to have this one right here, and that is going to give me now 120. Alternatively, what we could have done is the number of sides minus 2, which is 4. 4 times by 180 would give us the sum, and we could split that by 6. There's an alternative approach yet again. You can decide from here. So if I went ahead now, and another way that we could look at this is to connect the vertices. So if I connect the vertices now of this, we can go ahead and consider now each of these angles right here. So if we wanted, one way we could do it was to say, well, that's one angle, that will be the same, that will be the same, that will be the same, this one and this one will be the same. We know angles around a point are going to be equal now to 360, so each of these is going to be 60. So this is 60, this is 60. That one is 60, that one is 60, we got 60, and we got 60. We've now created these triangles inside the regular polygon, the hexagon, and we can say now that this angle right here and this one must sum to give 120 degrees. We've got 2 equal sides, so this one would be 60 and this one would be 60. If we think about it now, this is going to be 60, this is going to be 60, and so on and so forth. So we can say this entire angle is going to be 120 degrees. I personally don't like it like that, but it's entirely up to you. So with this one, we have an exterior. I like finding the exterior first. 60. We've got now the interior. So we've got the interior, which is going to be 120. And then we're going to have now 6 lots of those, which is going to give me that the sum of the interior is going to be now 720. Or you could have just done n minus 2 multiplied by the number of sides. So let's do the next one. Let's see what we got here. So I'm going to find now the exterior. So the exterior, how many sides have we got? We've got 7 sides. So if I go ahead and do 360, so 360, and then we're going to divide that by the number of sides, which is 7. That's going to give me now 51.42. So that's going to be 51.4. And then all we're going to do is this angle right here is going to be 180 minus the 51 point ... So let's go ahead and find that. So if I do 180 minus my answer, that gives me the interior, which is 128.6. I mean, you can do that in your head if you like, and that's correct to one decimal place. Therefore, the sum of the interior angles is just simply going to be 7 times this value. So each of these is 128. Let's put this on, 128.6 to 1 dp, and all I'm going to do is multiply that by 7. So if we do that, we can go ahead and we can just multiply this up. So multiplying that by 7, that is going to give me 900. Alternatively, what I could have said is that this is n minus 2 multiplied by 180. So 180 multiplied by 7 minus 2, that will give us now the 900. We could have divided this by 7 as it's regular. That gives me now one of the interior angles. The exterior will be 180 minus that answer. So we end up now with the 51.4, as you can imagine. So hopefully that's is just different ways of looking at it. We'll do one more. Let's go ahead and just do this one right here. This is an octagon, 8-sided shape. So if we do that, 360 divided by 8 gives me the exterior, and that is going to be 45 degrees. If we think 360 divided by 4 is 90, so it's going to be half of that. Therefore, this one is going to be 135, and then we would simply multiply 135 up by 8 to get the sum of the interior angles. So this is the size of one interior angle. The sum is going to be now 8 times by that number. Often students get this confused. 1 is going to be one lot of it, the sum is 8 times it. And this is one of the exterior angles. Of course, the sum of the exterior angles will always be the 360. Okay, let's go on and look at a couple of questions. In this question, we're told A, B, C, D, E, F, G, H is a regular octagon. We're asked in part A, what is the size of angle X? And B, what is the size of angles Y and Z? In C, what is the size of angle A, B, C? And what is the size of the exterior angle D, E, J? Okay, this is where we're kind of going before. If we look at this now, what we've got is a regular octagon. So we know that this sum around the centre, around a fixed point, gives us 360. So 360 divided by 8 gives me that this angle is going to be 45. So if we think about this now, what we have are these two sides which are going to be the same. So if we consider now what I've got as an isosceles triangle, so we can say that each of these are going to be what's left over from the 180, which is 135, divided by 2. What's that going to give me? 67.5. So that's going to give me now 67.5. So we can say that X is going to be 45. Y is going to be 67.5. That must mean that Z is 67.5 because we know we've got exactly the same just here. So we can say then that this one is 67.5. Therefore now this angle right here, which we've got, is going to, and we want the angle ABC. Now the angle ABC is going to be this one just here, which I've just, let me just put this on. So I'm kind of killing the question in one go. That is the angle ABC. Well, it's just the sum of these, which is going to be 135 degrees. So we know that. We then want to find now the size of the exterior angle. Well, the exterior angle is this one, which is DEJ. So D, whatever we've got in the middle, is the angle we're going for. So if we see E in the middle, that's where it's at. And we know what this is going to be. This is simply going to be the 45 degrees. So we have the 45 degrees like so. That is the exterior angle. And again, entirely up to you on how you want to find them. That's kind of going back to this idea right here. All we've done is used it for an octagon. I actually prefer one of these approaches rather than to split it up, but it's entirely up to you. Right, the sum of the interior angles of a polygon is 1620 degrees. In part A, how many sides does the polygon have? So this one is slightly more tricky. We know that the sum of the interior angles of a polygon are going to be 180 multiplied by n minus 2. So that's going to give us now 1620. So all we're going to do is just solve a little equation. So what we can say, dividing both sides by the 180, 1620 divided by 180 will be equal to n minus 2. So what we have is n minus 2. That is going to give me 9. So if I think 1800, if I said 1800 is going to give me 10, so 180 off that. So that now is going to give me n minus 2 is 9, so n will be equal to 11. The number of sides of this is going to give us 11. So if we just look at that, let's see if we can, if we got, I don't think we've got an 11-sided shape. No, we'll leave that as is. So that now is the number of sides. So how many sides does this polygon have? If the polygon was regular, what is the size of each interior angle? So if we consider now we've got 9 sides and we've got therefore 9 angles. So all I would do is take now the sum of the interior angles and divide it by the number of sides that we've got. So we can say now that the sum will be equal to 1620. We want to know now if this was regular, and this is the important bit, what's the size of each interior angle? So we can say that all we're doing is splitting that equally across 11 angles. And let's just go ahead and do that. So what have we got? So 1620, and then we're going to divide that by 11. And that gives us 147.3. So let's say that's 147.3, and that's to 1 dp. And it says in part C, if the polygon was regular, what is the size of each exterior angle? Well, if we think we've got 2 different choices. We can either do this now from 180, so 180 minus this answer, which is going to give me now on here the 32.7, so the exterior. Remember, this is 1 interior, 1 exterior is going to give me now 180, and I could write that it's 180 minus the 147 point dot dot dot. And we can see now that to 1 decimal place, that gives us 32.7. So 32.7 degrees. Alternatively, knowing this was regular, all I needed to do at this stage was say 360 divided by the number of sides, which is 11. That will go ahead and give me the answer we have. So nice question. This is working it backwards. Okay, let's finish with one more. The exterior angle of a regular polygon is 24 degrees. In part A, how many sides does the polygon have? So this is regular. So if we look at this, let's just draw a quick sketch. So we'd have something like this. So if I say now, it's going to look something like so. So if I go ahead, we can just look at that. And this is going to be 24 degrees. Let's put 24 rather than 240. That hopefully should have been, there we go, let's get rid of that. So this is 24 degrees. So we know that if this is 24 degrees, this one is going to be 156. That's the interior angle. So you've got 156 degrees. Lots of different approaches with this. We know for the exterior angles, one exterior angle is going to be equal to 360 divided by the number of sides. So we can say that 24 is going to be equal to 360 divided by the number of sides. So the number of sides will be equal to 360 divided by 24. What's that going to give us? That's going to give us 12. Let's just put that in. So what have we got? 360. 360 divided by 12, 15. That's 15. There we go. So the number of sides is going to be equal to 15. That is what we have. So how many sides does this polygon have? It then says what is the size of each interior angle? Well, we've just done that on a straight line. 156. What's the sum of the interior angles? Well, we got 15 times by that. So if we go ahead and do that, all we need to do is 15 multiplied by our value, which is going to be 156, and that will give us the sum of the interior angles. 2340. So 2340, and that is the sum. So if we look at that, that's what we're going to get. So if you wanted another way of thinking about this, if the sum is 2340, we can say now that the number of sides minus 2 multiplied by 180 will give us this value right here. This is just another way of looking at it. So if we divide this by 180, so divided by 180, that gives me now on here 13. So n minus 2 to check this is equal to 13. So the number of sides is going to be equal to 15. You don't need to do that, it's just an alternative approach. So there we go, a few different techniques to look at finding the interior and exterior angles of polygons. These properties now that we've just looked at only work for regular polygons, but we can look at the sum of the interior angles of irregular polygons like these and then consider basic angle facts.